Welcome to Stars Launch Pod, where we chat with innovators who are overcoming challenges, pushing boundaries, and collaborating to make space more accessible and sustainable for humanity, one launch at a time.
It's one small step for man.
Here's your host, Susan Wise.
Welcome to Stars Launch Pod, Space, Technology, and Research Sciences, brought to you by starsciences.org, where we connect, collaborate, and accelerate. I'm your host, Susan Wise, and joining us is Dr. Gabrielle Caswell, an Australian space advocate and the founder of Spaceport Australia, an independent research hub focusing on space health, human factors, and biological and technological solutions for space exploration. And since we chatted for about 15 minutes before we started this podcast, I get to call you Dr. Gabby. Welcome to the show.
Thank you, Susie. Thank you so much for inviting me.
Well, we'd like to hear a little bit more about you, if you would, and also what you're currently working on to further the space industry.
Oh, wow. We've got loads of projects, but I guess a little bit more about me. I am a clinician. I'm a doctor, as I'm always referred to in the US. Yes, I do see patients still. And I'm a rural remote practitioner in Australia. So we work a little differently in Australia. We're procedural. So rural general practitioners in Australia, we deliver babies, we do anesthetics, we operate. It's a very broad skill set. In fact, the one I would argue, this is the skill set we need to put doctors in space and on colonies with, cradle to the grave, but we also do a lot of trauma management and all that type of stuff that I think in subspecialized communities is sort of, pulled out, whereas we do the lot, so to speak. I often sort of joke we do everything with a pocket knife and a coat hanger. So usually sterilised. I would add sterilised, but I do all my emergency work on the side of the road, actually, waiting for the choppers to come in and pick people up. But, so we work a little differently in Australia. And one of the things being rural, obviously, is we have a huge streak of independence and a huge streak of autonomy. I think they're all good things. My interest in space, to my childhood, I've never not been interested in space and the possibilities of space. Obviously, as I've sort of trained as a doctor and I have other disciplines under my belt as well, I've sort of really begun to appreciate that humans are really stuck in 9 meters per squared gravity. Anti-physiology is geared to this, which is why we have problems in gravity that's 9.8. So it's a fascinating concept to go to space as a human when we're really sort of biologically bonded to the planet. Mm-hmm. And that's what we work on, because if we're going to go to space as a race or as a species, we need to be able to live, survive well in space and procreate, which is really the big one.
Right.
Otherwise, it's a one-way trip, so to speak.
Mm-hmm.
So it's a real conundrum we've come into. And one of the problems that we see is that all our trips to space have been rather short, okay? Real space, because the station is actually in low Earth orbit.
Right.
It's not space, so to speak. And we really haven't had anyone live, quote unquote, in space. They visited, like a weekend away in New York, but they haven't actually lived in space. Mm-hmm. And that brings an entire range of problems that need solutions. For example, you've got to take everything with you. Okay, you have to be independent. You have to be able to grow your food security, food independence. Your systems need to be fixable. And this is one that we find very much, I think the analogy of being in the army is very important in that you can't just call on supplies. You can't just keep sending stuff up. Everything has to be fixable. So really sophisticated tech is possibly not going to be what we take to space. So when we got thinking about it, there were two provocations for putting together Spaceport Australia. The first was what I perceive as we call scientific stagnation, that we're not including everybody who can do science in science, whatever the science is. And that means that we have a lot of people who don't make it through the university system that could contribute.
Right.
And come up with solutions that people who have been trained in a certain way, which was what universities do, we train them in a certain way, that we won't think of. And people argue with me about this all the time. And I say, well, you show me one .com IT billionaire, squillionaire that's got a university degree. Haven't you been proven wrong here?
I think you are correct.
Exactly. So, we have this sort of gap in our knowledge, and we also have the gap in what I call practical knowledge. So it's great to be sophisticated, and it's great that we can offer sophisticated medicine and sophisticated solutions, but those sophisticated solutions require a lot of support to deliver. But they're not necessarily going to be at the hands of a doctor on a colony on Mars.
True.
So
You're gonna doctor yourself, I guess.
Exactly. So it leads to this sort of, okay, well, let's just step back a bit. If we're going to put people on Mars, what do we need? Well, we need a habitat that they can live in. We need something that they can grow food in. So we designed a bio-regenerative habitat that is no waste. There is no waste.
Oh.
Everything can be recycled and reused and put back into the system. We use biological elements to make it completely radiation-proof because radiation's an issue.
You use biological elements, like...
Yeah. Well, we can't talk about that. But,
Okay.
but we then went one further.
Okay.
We've made a soil that's radiation-proof biologically and based on 10,000-year-old technology. Because I am actually a trained archaeologist in the other things that I do, which allows me exposure to a very broad range of literature. But I'm also a trained scientist, as in a straight scientist, so an ecologist. So I view the human body as its own ecology. And once we start to think about it as an ecology, then we need to make the environment right for the ecology. And we need to make the environment the humans are living in the best for their health, because we're integrated with that environment. And it's a concept that we're getting to, because in Western medicine, it's like, if it's bad, cut it up. If it's an infection, let's kill it. We have the tools that have given us the longevity, but part of the process is we've lost our connection, perhaps, sometimes to the environment that makes us human. So we know that if you go for a walk in the forest, for example, your immune system gets a boost. Boom, boom. So what does that tell you?
We need forests.
Exactly.
On the moon.
We need an oxygen,
on Mars.
Yeah. And we need an oxygen factory on Mars.
Exactly.
Well, this is where, I guess the intersection, when we come from a very highly technological base, that we have to revert to biology. It sometimes is a bit of an uncomfortable blend for engineers, because engineers, well, they control everything until they don't. Okay? And that's the problem we have, is that if we're not engineering for the human, then the human's not going to do very well. And people say, oh, you're a little bit hysterical about this. I mean, oh, really? It takes 3 to 120 days for the immune system to collapse in low Earth orbit.
That's not very long. You don't get to stay there very long.
And what predicts 3 or the 120 days of collapse? We don't know, because it's maybe genetic, maybe phenotypic. Then we have the issue of, that we have the problem of radiation, which I think we understand quite well. But what we don't understand is microgravity. And microgravity is a whole world of difference, and its effect from a molecular construction to the way it affects the human body, to the way the human body works in space. So this sort of got us thinking, well, let's start with what we call in medicine first principles. So first principles is when we're looking at a problem, and this is what House does. Everybody loved House, the program. And he was always taking everything back to what we call first principles. So we have a difficult patient. We can't work out what the problem is. So you work through it systematically, and you go back to first principles. So first principles is how something should work and why, you highlight where it's not working. So therefore, then you problem solve on the not working. So that's literally the application of what we do at Spaceport. So we bring in a load of different people. They all work together on projects. They're spaced around the world. All space enthusiasts, all have different skill sets, all have different training. But we work with the problem, and then we work back to the solution, rather than making the technology to fit a problem. So we don't come up with a technology that, we think this is going to be really good for this. Okay, how can we use it in space? We work backwards the other way. with the biology as the center focus. In other words, we want the healthiest biology because healthiest biology is going to live the longest. And there are other problems in space. For example, we have carbon dioxide toxicity. So in an enclosed environment, and it's a multitude of things. Remember, humans are their own ecological system. So in a closed environment like the space station, what we get is all your gut flora becomes generic. So you've got different gut flora to mine. I've got different gut flora to my neighbour, because it is designed, you get your first bugs as you're born from your parents and your local environment, what you eat, what your genetics are. And it's sort of finely attuned. There's only about 5,000 of them there in your gut. Don't think about it too much, because it's really starts to freak you out a little bit when you realise what's sitting in your tummy. But it's really important we understand.
Because my mom would always say, crawl around the floor, eat some dirt. It'll build up your immune system.
Absolutely.
You're a kid.
Absolutely. Mine all ate dirt, and they're like, my shortest is 6'4" and he hasn't had his growth spurt yet.
Okay.
But absolutely. And that's because your gut is intimately tied to your environment. And it's a difficult one for people to get round, because your gut controls your hormones, your thinking, your health, your bones, your skin, your cognition. Big one.
Yep.
Okay? Huge one. Now, we couple the genericization, it's not a word, I've just made that one up, of your gut in a closed environment. And we don't really know how it works, but it's been the first space flight since about 1972. I've got a paper. They recognized it happens. But we didn't recognize the importance of the gut interplay with the human body. So if that gut becomes generic, you might technically be malnourished because you don't have the right bugs for you. And we can upregulate some of those bugs with the right food to make them work better, so your body works better.
But you need good food if you're making it in space. It's got to be, there's the cycle,
Yep. And this is where I have a bit of an issue with hydroponics, because a good walk through the forest boosts your immune system. We need soil, and soil is an ecology.
Yeah.
And there's an interaction between the soil and the food and the plant and the nutrition and your own body's behavior. And this is the connections that we're trying to sort of bring in without having to eat green slime,
right,
and awful stuff. We
that doesn't sound long term.
No, not for me. But the other problem we've got, is humans are social. Okay, so we've got people in a very artificial environment psychologically. And one of the most primate bonding things to do is to share a meal.
Right. Yeah.
It coheses people, brings in a team spirit.
Yep.
And causes discussion, diffusing of the days, whatever, and the issue is if you're just having green slime and you're having
The
green
romance
slime.
in that.
Do you know what I mean? And then we're losing maybe the psychological things that we need to build into these environments. And it's one thing to be functional, but if we're going to send people up to be functional and we choose them just on IQ, it is the EQ that will destroy the mission. And I guess being a clinician, where I could treat the whole human, my view of how we make environments robust to support the human goes down to the level of the nutrition. So this is how we ended up with a sort of biological life support systems, basically. And then when we built the habitat, we've dealt with the radiation, we've created the soil, we've got rid of all the biological waste that can be reused into the system. So there's no waste in the system, absolute no waste. Nothing is wasted.
Right.
So then what we did is on the inside of the habitat, we thought, well, if we jig it a bit, we can boost the immune system. Why not? Increase the health of the mitochondria. Why not? It's pretty easy to do when you know what you're doing. And make an enclosed system that can be scaled. We can drop it on an asteroid. It can be enclosed because, of course, on Mars, we've got problems with the soil because it's got so much perchlorite in it.
We can put it on the moon.
Yeah. Well, the moon, you can drop it on the moon, but we can use the regolith into the soil. Okay, so we send out, I say to people, it's a bit like we make a starter culture with yogurt.
Okay.
Everyone gets it? I made a starter culture with the soil. Take up a ton and then use the local resources and all your waste to increase your soil. But you've got the good stuff to start with. Does that make sense?
Sure.
Yeah.
You,
So
you
this
have
is
a,
sort of-
it seems like there's a lot of challenges ahead, a lot, and you're
Oh.
overcoming them one at a time. I want you to talk about maybe your biggest aha moment.
I think it might have been linking maybe the human ecology to the microbiome to maximizing human phenotype. So phenotype is the genetic expression. So the genes are what gives us our traits. Your phenotype is the end result that you end up being. Okay.
Okay.
Now we can maximize the phenotype. So we can increase or upregulate the phenotype expression. So, for example, when we condition athletes, we upregulate the athlete to the environment that they're going to be in to run.
Right.
We do that somewhat with astronauts at the moment, but what we do with astronauts is we upregulate them so they're more robust than normal, so that when they come back to Earth, hopefully they're close to normal.
Got it. Because,
Got it?
you know, everything starts breaking down when you're up there. And by the time you get back, you want to at least be even keel.
Exactly. So
Okay.
we're not going to be able to do that when we move further away from Earth
True.
and on longer expeditions. Okay. Because we haven't conquered gravity. And I don't think we're close to even producing artificial gravity. But even if we do, Suzanne, what I keep saying to people is that we're only about 10% down in low Earth orbit on Earth's gravity. But look at the issues that we have. What happens when we're 50% down? So it starts to become, yeah. Okay. And if it's so expensive to get people to Mars and it takes so long, what do we do to support those individuals, you know, in these basic physiological functions that we don't master yet? So one of the things we worked on is creating a supplement that takes in the ecology and the microbiome and looking at the phenotype, which increases the uptake of oxygen in the human lung in low oxygen environments.
Oh,
Okay,
that's
because
fantastic.
So carbon dioxide is toxic, and the carbon
Right.
dioxide toxicity plus microgravity, because we have to put that in there. It's never one thing, as I say to people. It leads to a decrease in cognition. And if
Not
we
good.
are, well, it's not good, but remember, we're sending out superhumans at the moment because they are what I call the athlete astronaut, but they've also probably got an IQ of 180. I wouldn't want to be in the room with them at times. They've got double PhDs and all this sort of things. So you lose 20 IQ points off them, you probably wouldn't notice. But we will have people who work in space with the average 110 IQ, and if we lose 20 off them, in Australia, the level for sort of what we consider disability is 80 IQ points.
So is this supplement your aha?
I think it was. It was like, let's not combat the environment because we've got really good carbon dioxide scrubbers up there, the best in the world almost. You know, will be outer world.
Yeah.
So why don't we get the human to better match the environment? And I think that was our aha. And then we started, that started the cascade of, hey, if you walk in the forest, your immune system gets a boost. So what do we need to do? Produce a forest. Correct?
Okay. Yes.
Yeah. And it just follows.
Easier said than done, but
well, it is
We'll see.
actually. But then we look at things, and I did have a little go at asthma this year because we did actually present a whole panel on biological life support systems. And for the life of me, I don't know why we do all this research in dwarf wheat, because the human microbiome actually does better on barley.
excuse me, on what?
On barley. So
On
out of the
barley.
full
Oh,
barley.
okay, yeah.
Yeah.
Okay.
So we do all this research on dwarf wheat, but
Yeah.
biologically, humans
better in barley.
do better with barley. It's better
Beer.
for the microbiome.
So
And
you
the
need to be taking
microbiome.
beer up there.
And you can make beer as well. You can make wheat beer too. And beer and bread are the mark of, you can actually trace, I did a whole project on this, you can actually trace the rise of civilization in agriculture through the beer and barley.
I like where you're going with this.
I actually made, here's a little tidbit, I made 5,500-year-old Sumerian beer.
No.
It was disgusting.
I was going to say, is it good?
But beer is an interesting product in that it will create more nutrients than the inputs you put in. So it's a very rare food. So they will probably be making some form of beer in space. There
I
you go.
love it. That's
Because
great.
it provides more nutrients than inputs. So one of the rare things. But as a beer maker, I think I should stick to spirits.
Okay. Do you
But
have
that was one of our really big aha moments is,
Okay.
we can keep attempting to protect ourselves, but biology doesn't protect. Or we take what we have as a biology and make it better suited to the environment. And we made a supplement that increases the oxygen exchange in low oxygen environments and makes the lungs work better. And a whole lot of other things, actually, because it's also anti-osteoporosis, it's antiviral and antibiotic, and it's also anti-cancer in some respects. And this is all peer-reviewed, proven.
Well, this even sounds like something that would be important right here on Earth, not just.
Oh, absolutely.
for-
It's got
you know.
absolutely huge clinical
Yeah.
implications, particularly people undergoing oncology. I take it because somebody's got to be the guinea pig. And,
And look at all the energy you have.
that's it. And it's about, this is our ecology. So how do we maximize this in this environment, in this extreme environment? And I think the rules will sort of be the same, whether it's Mars, whether we're dropping people on a mining asteroid, whether it's Moon, whether it's just orbiting around and doing scientific experiments for 6 months on an orbital reef. I think this is, something we have to get our minds around, that we are never going to outtech biology. So therefore we need to learn to use biology
Yep.
for the space we're in. And it's been a bit of a journey, but I'm getting the engineers to my side because they're realizing, well, hey, she's right. We haven't got a solution for that one.
You're right.
And-
It's important work and it has to be done. So especially
Absolutely.
if they're planning to go to Mars or the moon or wherever we plan to go. Before we wrap up, I want to know if you have a piece of advice that you'd like to share with our listeners.
Look, I sort of think in my experience, when I opened Spaceport Australia, it was after 7 years of mulling. We were a bit slow on the uptake and discussing, and who's not being included in space was my first thing, from a talent point of view. Who are we missing because they might look at problem solving differently? Who's out there that's got a practical solution to something, which sometimes you don't see the forest for the trees, as we say, because we're very high tech in our training. But sometimes it's a simple solution, that works for patients in clinic, for, problem solving in more sophisticated areas. So it took us about 7 years to get to it. So then I opened, bit the bullet and I said, the government's not doing space. If I don't do space myself, they're not going to do space. So I opened Spaceport. A year later, blow me down, as we say, they opened a space agency and changed all the legislation out of nowhere. But by then we were established, and we were established on the principles that we have lost a cancer doctor that we call a practitioner scholar, and they were no longer contributing to the literature. But there's the people who come up with practical solutions. Okay? And so we now have a whole ring of practitioner scholars around the world researching and publishing peer review papers. We've done 10 papers this year, so it's quite academically high.
That's exciting.
And
yeah.
We're self-funding, which means I still have to see patients because we're self-funding. But we are now moving into a lot of really good partnerships and academia and reaching out. But the beauty of it is we're independent. So we can deal with anybody in the world. We can take anybody from South Africa to Malaysia through to, I've got a researcher in New York, Canada, somebody in Outer Hebrides in Scotland wants to do space. So we have a project, which is an all-in project, which is the Hamilton project, which is literally we are making Star Trek Doctor, the holographic Doctor. And then we're introduced to people who've got the holodeck. They've built the holodeck. So we've got the holodeck capabilities now. We've got the AI. We're training our AI very differently to how AI is trained. And, you know, I've had to learn a lot about languages. Fortunately, I was linguistically trained in one of my degrees, which people say, well, how's that relevant? And I said, well, you'd be quite surprised. Let's just wait till this AI come out, because AI hallucinates in medicine, makes things up. We can't have that, you know. No. And, you know, so it's sort of like, you know, it's problem solving, but it's problem solving on a grand scale. And as I said, I always say to the young people, because I encourage all the young people, the starters, look, you've got ideas that I won't even think about. Your brain is trained very differently to mine because they've had social media. So the neural nets are going to be very differently. They see things very differently. So we always encourage them, if they've got an idea, well, let's follow the idea through. And not to wait. I say to people, you know, you wait for permission. Okay. You wait until somebody allows you to do something. Space is not 9 to 5. Any career, and I'm sure this is even in your broadcasting career, Suzanne, you didn't just do 9 to 5. You've got to put in the extra hours. You've got to be committed. The most committed wins. And you have to have enough faith in your idea to follow it through, but enough insight, well, actually, it's not going to work because you've got enough body of knowledge behind you. So my advice to everybody is, look, don't wait, reach out. You'd be surprised at how welcoming the old heads are. So once they've got past their academic career and they, you know, because a lot of people who work in space, and my husband commented on this, he said, geez, they're all old. And they went, well, that's because the shuttle program was 40 years ago. We forget that. So a lot of my flight surgeons who have joined Spaceport Australia worked on the shuttle. They built the shuttle. We have that data bank, and they're ready to nurture and mentor. And you know, I say to people, don't learn it all. Go and ask somebody a question who knows, because then you can save that brain space for problem solving because you've accessed that. So don't wait. You know, don't wait. Don't be frightened of rejection. You just keep knocking on the doors, or you get off your butt and you get onto PubMed or any of those other open databases, and you start to read the papers. You start to form your own opinions. And even if your opinions are wrong, that's okay, because you've gone through the process of learning how to form an opinion and how to deduce and critique, which is really important. Don't believe everything everyone says to you. Go and learn it yourself. And that's what I always say. Don't be frightened. Go out there. You know, it's like trying on a new dress or a new look. Just go do it.
I don't think I even need to ask, but your passion project, this is your passion project.
Oh,
right?
absolutely. Absolutely.
Yeah.
And it went, I'm hoping it won't start and end with me. That's not the concept. The concept is, yes, it is a commercial business. Yes, we do have some commercial tech that we're working on. But what we do with a lot of the things that we work that way, for example, I have a range of children's books, which people are always a bit surprised, and they sell on Amazon. And what we do is, with the money we earn from that, we put it back into the science and the research, because publication fees are very expensive. So that offsets some of our publication fees. So that's how we sort of work. And the whole idea is that, you know, ideas are welcome. They're not all good ideas, but that's why you work through them. I always think that young heads can learn from old heads, and that when you're young, you have the passion and you have the lack of sort of sense of risk. And you have to remember, everybody in the Apollo crew, I think the average age was like 29. You know, remember what we were like when we were 29? Yeah, we did everything. When you get older and you get a bit more bruised and a bit more scuffed up, you go, oh, I think I don't really want to do that. But those young heads can learn from the old wise ones. And that's what we try and do, is sort of bring the two together. It doesn't always work, but that's okay. Right. And to sort of say to people, look, if you're committed to it, you know, commit. Doesn't mean you give up your day job. Everybody that we have works in your day job. But it means that, hey, you've got maybe 2 hours at night that you're watching TV and something on the idiot box. How about we don't watch the idiot box, you read a couple of papers? You know, that's 10 hours a week that all of a sudden you can put to something on a school night. You know what I mean? It might be exciting for you, that you're part of something bigger.
I love it. Thank you, Dr. Gabby. We appreciate you sharing your story. And thank you for being such a good steward for space exploration. It's just exciting, and I cannot wait to see the habitat. I cannot wait to see the results of all of these things that you're working on. And I look forward to the future and seeing all that happen. Thank you.
You're welcome.
All right, be sure to join us where we connect, collaborate, and accelerate. We'd like you to join us at starsciences.org. You can get a free one-year membership. Just put in the promo code FRIENDS321. That's FRIENDS321. If you enjoyed this episode, please leave us a review and subscribe. And until next time, keep looking up. Thank you, Dr. Gabby.
You're welcome. Lovely to have been here, Susan.
Don't miss an episode. Subscribe on your favorite streaming platform. Watch us on YouTube and follow us on social media. Stars Launch Pod, propelling us forward, one launch at a time.